Video, I'm going to review what happens to a certain point when you rotate an object about the origin right here in the middle. Because sometimes when you rotate this 90 degrees counterclockwise or 90 degrees clockwise, it affects this coordinate in a certain way. So we're going to say this point right here is the point 3 for x and 2 for y. And sorry about that, I'm writing that with the mouse, but that's okay. So that's the point 3 comma 2, 3 for x, 2 for y. And what I want you to notice is that point right there, when I rotate this either 90 degrees counterclockwise, and it ends up right here now, or if I took that and rotated it from its original position 90 degrees clockwise, where that new point location is. And the same rule applies every single time. If you have an object and you rotate it 90 degrees to the left, 90 degrees clockwise, that point that used to be 3, 2 right here in the triangle now rotates over here to the left after that 90 degree turn and ends up right here at the point -2 for x, comma 3 for y. So that point is -2, 3. And you can see this point is the flip-flop of 3, 2 with x negative. So instead of 3, 2, -2, 3. Excuse me, the flip-flop and x made negative. If I take that same object and I rotate it the other direction, so that is from here starting at 3, 2. If I take that and rotate that around the origin 90 degrees clockwise, I end up down here at this point, and that coordinate for x and y, if I look at it, is the point 2 for x, -3 for y. So you can see that is the flip-flop of this, but the y is made negative, and that happens every single time. A rotation, a 90 degree turn to the left, is the flip-flop of the original point with x made negative. A 90 degree turn to the right clockwise is the flip-flop of that point with the y made negative. So one more example of that, and that is this one right here. If I look at point A originally is 4 for x, comma 1 for y. So I went over 4 for x and up 1 for y. If I take that object and I rotate it 90 degrees counterclockwise to the left, it changes the position of that A point. So you can see it originally was right here at 4, 1. But now as I'm rotating it, watching that blue arrow do the 90 degree turn to the left, I can see after that rotation, it's now right here. And that's going to be close enough for me. And that is the point -1 for x, comma 4. So you can see I took that point and flip-flopped it and made the x negative. Happens every time. If I took that same point that used to be 4, 1 and I move that 90 degrees clockwise to the right, you can see that A point now is down here, and that point right there is the point 1 for x, -4 for y. So you can see 90 degree turn to the left gave me a flip-flop but the x negative. A 90 degree turn to the right gave me the flip-flop, but the y coordinate is negative. Happens every time. So 4, 1, 90 degrees to the left became the flip-flop, x negative, -1, 4. 90 degrees to the right gave me the flip-flop of that, 1, with the y coordinate made negative. Works that way every single time. And then one more point as an example. I'm going to look at point C now. So that point for C, if I look at it, is 4 for x and 5 for y. 4 for x, 5 for y. Over 4, up 5. If I move that rotate to the left, it's going to be a negative flip-flop. So it's going to be somewhere over here. And let me just write the point first, and then I'll do the rotation second. So I flip the points around. So instead of 4, 5, I write it 5, 4, and I make that 5 negative. Let's see if that works. So if I flip that 90 degrees, rotate that 90 degrees counterclockwise to the left, that point C that used to be 4, 5, let's see where it ends up. So 90 degree turn to the left, and I can see right there ends up at negative 5 for x, 4 for y. If I do that 90 degrees clockwise, I should get the flip-flop and also negative of that point. So that should end up being not 4, 5, but 5 with negative 4. And that is x and y. That's what I should get. The flip-flop with y negative. So let's see if that works. So here's the point up here at 4, 5. I'm rotating it 90 degrees to the right. And I can see it ends up, and that's close enough, at 5 for x, negative 4 for y. So again, one more time, you need to commit this to memory. A 90 degree turn to the left is the point flip-flopped, but x made negative. A 90 degree turn to the right is the flip-flop of that point, but the y made negative. So know that. Turn to the left 90 degrees, flip the point around, and then make the x1 negative. If it's going this way 90 degrees, flip the point around, but make the y1 negative. Of course, if I take it and move it 180 degrees all the way down, what I get is the same point but written negative. So that's the point negative 4 comma negative 5. That's what happens when I rotate that 180 degrees. Alright, hope this video helps a little bit. We'll probably use it for today's warm-up. Good luck.